Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about measure of dispersion. Now already in our previous video we have discussed about measure of central tendency, which is a very important topic in descriptive statistics. We understood about our applications with a lot of examples, and we saw a lot of things. Now in this video we are going to focus on measure of dispersion. First of all, we are going to go ahead with the definition, and then one by one we will see what are the common measures of dispersions that are specifically used. So first of all, as we go ahead with the definition, so here you can see measure of dispersion describes the spread or variability of a data set. Okay, they indicate how much the values in a data set differ from the central tendency, right? See, I may have some kind of random variable. In this kind of random variable, I may have any numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Now, in all these specific numbers, you know that there will be one mean, median, or mode, right? So one value will be there. We know what is the central tendency over here. But with respect to all the other distribution, we will be able to understand how our data is basically spread, right? So from this mean, if I have a number like 4, or if I have a number like 8, so how much far it is away from the mean, right? If I have a number 2, how much far it is away from the mean, right? In short, when we combine both of them, this is nothing but this is what we are talking about, the spread, right? So we are going to discuss many things over here, but just I am trying to give you an idea. So with the help of measure of dispersion, we try to describe the spread or variability of a data set. Okay. So there are 4 common measures of dispersion that we specifically use. One is range, then you have variance, then you have standard deviation, and then you have interquartile range. In this video, we will be talking about range, variance, and standard deviation. Interquartile range I'll discuss in the upcoming videos. Okay. So let us go ahead and first of all discuss about range. So what exactly is range and how we are able to see the spread of a data set? Okay. So if I probably go ahead with the definition of range, range is the difference between the maximum value and minimum values in a data set. Okay. So here, if I just want to probably talk about the formula of range. So range is nothing but maximum value minus minimum value. Okay. Now, just to take an example, let's say I have various ages of people, and it is mentioned like this, right? It is mentioned like 14, 13, 10, 20, 25, 75, 15, right? Now, from this particular age, if I really want to understand the spread, I can specifically use the range, right? Because I really want to know what is the maximum value, what is the minimum value. In this case, let's say my maximum value is 75 minus 10, which is nothing but 65. So in short, this information that I'm actually specifically getting, I'm actually able to understand like my data is basically having a spread with the difference of 65, right? So it starts from 10 and it is probably ending till 75. Okay. So let's talk about some of the characteristics again in range. So first characteristics is that it is very simple to calculate, right? Simple to calculate. Second, here it is very sensitive to outliers. Okay. Now let's say over here I have this group of ages. Okay. Or let's consider another example with respect to weight of a specific classrooms, right? So all the student weights would be over here, let's say like 35, 40, 45, right? Then you have this 39, 30, right? But suddenly there is one kid who is having a very good weight, and let's say the weight is somewhere around 70. Now in this scenario, when we try to calculate the range, right, we know that if I just remove 70, right, if I just remove 70, right now the range is nothing but it will be 40 minus 30, right? Hardly it is 10 if we remove the outlier. But if we add this outlier where a kid is basically having a weight of 70, that time my range will specifically become 70 minus 30, which is 40. Now here you can probably see the difference, right? And because of this outlier, this range is probably showing the entire different information, right? When we see from this. So this is really sensitive to outlier. And one more thing that you really can understand, it just provides a rough measure of dispersion. Rough measure for dispersion. See, when we calculate range, we are just taking the maximum value and the minimum value. We are just trying to find out the difference between them, right? But what about the other values that are present in this distribution? We are not talking about it, right? So it just provides a rough measure of dispersion. Okay, so these are some of the characteristics. Now, in order to overcome this kind of disadvantages, what we do is that we use the second type, which is called as variance. Now, this variance is really important, so please make sure that you understand it. So first of all, we will go ahead and provide a definition for variance. So let's go ahead and define variance. Variance measures the average squared deviation of each value from the mean. Okay, so again, see the definition. It says that it measures the average squared deviation of each value from the mean. So in short, we are just trying to find out how far it is basically from the mean. Okay, so if I really want to just add one more point, I can go ahead and write it provides a sense of how much the values in a data set vary. Okay, so here this is what variance is all about. Okay, but again, just by seeing the formula, we definitely won't be able to understand. So first of all, let me talk about the formula for variance. Right now, let's say that over here I will be taking when I'm talking about variance, again, since we know that whenever we talk about mean, also we talk about population mean, we also talk about sample mean. So here also I'm going to go ahead and discuss about population variance, and the other one that we are going to discuss about is nothing but sample variance. Okay, so both of them we are specifically going to discuss. For population variance, there will be a simple separate formula and all. Okay, so population variance is given by a symbol sigma square, which is nothing but summation of I is equal to 1 to capital N, because this is my population, right? We have to probably go to the N. Now it shows, right, variance measures the average squared deviation of each value from the mean, right? Average squared deviation, right? What does deviation basically mean? It is nothing but it is the difference of your data point minus mu, the population mean, whole square, since we are just writing squared deviation, right? So squared deviation basically means deviation is nothing but with respect to any data point minus the population mean whole square divided by capital N. Similarly, if I just go ahead and consider sample variance, it is written by it is given by symbol S square, and here I'm just going to use summation of I is equal to 1 to N. Here I'm going to write x of I minus x bar whole square divided by, instead of just using capital N or small n over here, we will go ahead and write n minus 1. Now I will discuss about detailedly why this sample variance is divided by n minus 1. A dedicated video will be created, next video, why our sample variance is divided by n minus 1. Okay, but just right now, just consider that for this sample variance, we need to find out the average square deviation of each value from the mean divided by your, when I say average squared, here we are specifically dividing it by n minus 1. Here we'll divide by capital N. Okay. So first of all, let's understand what is this x of I. X of I is nothing but, let me just go ahead and write. So here you have this x of I. X of I is nothing but these are the data points. Okay. Then mean you have here, it is basically called as population mean. Okay. Then here you have capital N, which is nothing but your population size. Okay. Capital N is population size. Similarly, if I go ahead and write over here, x of I is nothing but your data point. Data points. Okay. X bar is nothing but your sample mean, and N is nothing but your sample size. Okay. Now, as I said, why specifically we need to divide this by n minus 1, I will discuss that in our next video, because I actually require around 10 to 15 minutes to explain that particular topic. Okay. But let's solve a problem. Okay. And then based on this particular problem, we'll just try to find out the population variance or sample variance, anything that you can specifically use. In this case, I will just go ahead and compute the population variance. Okay. So since we are discussing about the variance over here, so let's go ahead and see one example. So here I will take an example. Let's say in our data set, the data set can be anything. Let's say I have the size of flower petals. Okay. Let's say I have a size of the flower petals. So the size is nothing but 5, 8, 12, 15, 20. Let's consider this. Okay. The unit can be centimeters or whatever you like. You can basically go ahead and do this. Okay. Now from this, we will just go ahead and calculate what is the variance of this distribution. We'll just go ahead and calculate it. So let's quickly go ahead and calculate it. So first of all, based on the formula, I have this specific formula. So I will just go ahead and copy it. I'll consider that this is my population. Okay. So this is my formula for my sample variance. Okay. So quickly, the first thing that I need to, oops, just a second. Oh, I will just go ahead and copy this and I'll paste it over here. Okay. So this is the formula that we are going to use. Okay. So first of all, we need to go ahead and compute the mean. So here our population mean will be mu, which is nothing but 5 plus 8 plus 12 plus 15 plus 20 divided by 5. Okay. Now here, once I probably go ahead and divide by 5, if you do the calculation, I'll be getting 12. Now in order to compute the variance, you know that I have to probably go from I is equal to 1 to n. So I is equal to 1 basically means this, 2, 3, 4, 5, like my entire population size, n is nothing but 5. So I have to iterate through each and every element and probably do this particular operation. So let's do this. So over here, what I will do, first of all, x of I, that basically means x of 1. I will go ahead and take 5 minus 12 whole square. Okay. Plus 8 minus 12 whole square plus 12 minus 12 whole square plus 15 minus 12 whole square plus 20 minus 12 whole square divided by the total numbers are 5. Now if I go ahead and do the calculation, it is nothing but 27.6. So this is specifically my variance. Okay. Variance with respect to the spread of my entire data. Okay. So if I probably go ahead and determine some of the characteristics of variance, let's go ahead and define this. Okay. So I hope you got an idea how to calculate the variance. So here the first characteristics is that it provides a precise measure of variability. Okay. It specifically provides a precise measure of variability. Then here the units are squared of the original data units. So see, what is basically happening over here? Since we are finding out the difference, but we are squaring it over here, right? And because of this, we are changing the units. So units are squared of the original data units. And the third point over here, these are also very sensitive to outliers. Then the range. These are more sensitive when compared to range. If you don't believe me, just go ahead and add 100 for this value and try to calculate the variance. The variance will shoot up like anything. Okay. The reason is very simple, because we are squaring it over here, right? So this is about variance, and I've discussed about population, I've discussed about sample variance and all, right? One important property about variance, right? Whenever you have a data, let's say I have one distribution of data, and let's say over here, this is my data distribution and this is my spread. Let's say for some variance value, I have this kind of spread. If I have another distribution, and let's say if my spread looks something like this, where it is less spread, right? So here you will be able to see this variance will be less when compared to this particular variance. Okay. So this variance determines the spread of the data that you are specifically having. Okay. Now still variance is not able to, because we are taking a square of the original data units, right? But still I'm not getting that information. Let's say if this is my mean, if I want to go ahead and check, hey, let's say I want to go ahead and check about 8, how far 8 is away from the mean. This is 12, right? But still I don't have that information how far 8 is away from the mean, right? So to calculate this specific information, the third technique that we specifically use is something called as standard deviation. And standard deviation formula is very simple, whether you calculate population standard deviation and all. But first of all, we will just go ahead with the definition. So definition is very simple. The standard deviation is the square root of variance. Right? So if I just go ahead and use the same formula over here, I got 27.6, right? So if I just go ahead and calculate the standard deviation, which is given by sigma, it is nothing but it is root of this particular value that I have actually got, square root of variance, right? 27.6. So if I go ahead and calculate this, it is nothing but it is 5.25, approximately this value 5.25. Okay. Now, what does this standard deviation basically say? See, let's say I have a numbers over here. So let's say my mean is 12. Then if I go one standard deviation to the right, the next number is basically going to be 17.25. Why? 12 plus 5.25, right? So this is basically one standard deviation to the right. Then similarly, if I go one step more further, one standard deviation to more further, then the next number will be 17.25 plus 5.25, right? So this is nothing but 22.5, right? So this is nothing but this is second standard deviation, right? So this in the second standard deviation away from the mean, I have 22.5. Similarly, if I go on the left hand side here, what will happen? I will take this 12 minus 5.25. So 12 minus 5.25 is nothing but 5.25. It is nothing but 0.75. And here we will specifically take this. It is nothing but 6.75. Then again, if I go ahead and subtract 6.75 minus 5.25, I'm going to get 1.0, right? So if I go one standard deviation to the left, I'm going to get 6.75. If I go second standard deviation to the left, I will be getting 1.0. Now from the data set that I have, specifically have, right? Let's say I have this particular data set 5, 8, 12, 15 and 20. Now if I have a question, where does 20 fall in this distribution? So here I can say, hey, within the second standard deviation, right? So within the second standard deviation, somewhere here 20 may fall. How to find out the exact value, how many standard deviation away from the mean? So for that, we will be using something called as Z-score. So this Z score we will discuss in the later stages. So for this you need to have an idea about what is standard normal distribution, and before that you also need to know what is normal distribution, right? So we will discuss about this if I really want to exactly know that how many standard deviation it is away from the mean. But just to get this idea from this particular standard deviation, you know that 20 will probably fall in the second standard deviation. If similarly if I talk about 5, it will fall in the second standard deviation from the left, right? From the left of the mean. This is right of the mean. So this information you are specifically able to capture it from the standard deviation. Okay. So considering this, let's now go ahead and discuss about the characteristics of standard deviation. So the first characteristic is very simple. It provides a clear measure of spread in the same unit. This is very important. In the same unit, because we are doing the square root, okay, as the data. Second thing, this is also sensitive to outliers. So if variance is increasing, obviously this is also going to increase, right? That is very simple. Third thing, this is commonly used, or this third point I will discuss about later once I discuss about IQR, okay? But right now, these two main characteristics are specifically there for your standard deviation, okay? Now, this was all about the discussion. I know there is one more topic which is called as IQR. To understand about IQR, you need to know about percentiles, okay? Percentiles. So this pre-knowledge is specifically required about percentiles. So first of all, in the upcoming topics, you'll be seeing after a couple of videos, I think, I'll be discussing about percentiles, and then we'll also go ahead and discuss about interquartile range. We'll also discuss about 5 number summary. All those topics will specifically come. But this was all about measure of dispersion, okay? And again, guys, understand one thing over here is that don't get confused with standard deviation and variance, right? Here we are doing specifically squaring it up, right? In variance, and in standard deviation we basically find out the square root, okay? So see, this was all about this particular topic, and I hope you are able to understand this. I will just go ahead and provide you some key differences of key differences and similarities between standard deviation and variance, so so that you can actually read it, okay? So in this particular material, I will just go ahead and paste some content so that you can refer it for your reading purpose. So yes, this was it from my side. I hope you like this particular video. I'll see you in the next video. Thank you.